You know, every time you click, stream a movie, or ask an AI a question, you're tapping into these massive data centers. They're the invisible engine of our digital lives, but man, are they power hungry. And that hunger is becoming a huge energy problem. So today, we're going to look at a truly revolutionary solution from the Japanese telecom giant KDDI, and it involves giving servers a bath. Okay, so let's dive right in. Before we get to this pretty wild solution, we really need to wrap our heads around the scale of the problem we're facing. This isn't just about a few extra computers humming away. It's about our entire digital world bumping up against its physical limits. And there you have it. That's a quote from the CEO of NVIDIA, and it's absolutely staggering. Just think about that. In only 5 years, the energy footprint of data centers has quadrupled. I mean, that kind of growth just isn't sustainable, and it's forcing the entire industry to rethink everything from the ground up. So why is this happening? Well, this slide tells the story perfectly. The servers that are powering today's AI and cloud services are just ridiculously more powerful than they were a few years back. We're talking about processors with what's called thermal design power, or TDP, of over 350 watts. All that computing power creates an insane amount of heat, and our old method of just, blowing air on them, it's quickly becoming a losing battle. So if air isn't cutting it anymore, what's the next move? Well, KDD's answer is, well, it's pretty radical, but also kind of brilliantly simple. Stop using air altogether and just submerge the servers directly in liquid. And this is what that actually looks like. I know it seems completely wrong to dunk expensive electronics in a liquid bath, but here's the thing, that is not water. It's a very special, highly engineered cooling liquid that is a total game changer. Okay, so let's put an official name on it. It's called immersion cooling. And the magic words right there are electrically insulating. This dielectric oil can suck up huge amounts of heat, way more efficiently than air can, but it does it without causing a single short circuit. The heat just transfers directly from the hot chips right into the fluid. It's incredible. So how does the whole system work? Well, it's this really elegant, closed-loop cycle. First, you immerse the servers, and the oil instantly pulls the heat off them. Then, that now hot oil gets pumped to a unit where it transfers its heat over to water. From there, the warm water is piped to an outdoor unit that just uses the outside air to cool it down. They call that free cooling. And finally, that now chilled water cycles right back to cool the oil again. It's just a super efficient way to shuttle heat from inside the chip all the way outside. So the big question is, does all this crazy engineering actually work? Well, the results from KDDI's multi-year tests are in. And honestly, they're pretty astonishing. They really do speak for themselves. There it is. That's the headline number. A 94% reduction in the amount of power needed just for cooling compared to a normal air-cooled data center. That isn't just an improvement. It's a monumental leap forward. And this number is just as impressive. It's something called power usage effectiveness, or PUE. Now, in the data center world, a perfect PUE score is 1.0. That would mean every single watt of power goes to computing and 0 goes to things like cooling. So hitting a score of 1.05, that is unbelievably close to perfect. And this table here really puts it all into context, doesn't it? Your typical data center might have a PUE of 1.7 and use 70 kilovolt amps just for cooling. KDDI system, a PUE of 1.05 using a tiny 4.5 kDa. The overall power savings are just massive. But wait, there's another incredible benefit. When you get rid of all those tiny screaming server fans and the giant air conditioners, the whole system becomes incredibly quiet. We're talking a 35 decibel drop in noise. That's the difference between a subway train roaring by and just having a normal conversation. This opens up a whole new world of possibilities for where you can put data centers. Think small-scale computing power in office buildings or even near residential areas. Okay, so let's look at how they pulled this off, because achieving these kinds of results wasn't as simple as just dropping some servers in a fish tank. It took some serious next-level innovation. So to get standard off-the-shelf servers ready for their new life underwater, or under oil, they had to make some key changes. The biggest one was yanking out all the internal fans. Right there, that saves about 10% of the server's own power consumption. Then, things like the thermal grease on the processors and even the standard cables had to be swapped out for special oil-compatible versions to make sure everything would work reliably for years. Now this is super cool. This is a great example of hardware innovation. The engineers used fluid simulations and figured out that the tightly packed fins on a normal air cooling heatsink actually block the flow of liquid. So they designed a new one with fins that are thicker and spaced farther apart, specifically for liquid. And the result? A 1.24 times improvement in cooling performance. Just brilliant. Of course, none of this works without the right magic ingredient. KDDI and its partners developed this special, high-purity hydrocarbon oil. It's fantastic at transferring heat, sure, but it's also designed to be incredibly stable so it doesn't break down over time. That long-term stability is absolutely essential for keeping maintenance low. So what does this all add up to for the future? Well, this is so much more than just a successful experiment. It really feels like it's signaling a fundamental shift in how we're going to build the data centers of tomorrow. And, this success story didn't happen overnight. It was this really methodical three-phase process. It started back in 2020 with a prototype in Taiwan, then moved to a more refined container model in 2021, and finally it all came together in the full-scale high-reliability test in 2022. This step-by-step approach proves that the technology is robust and totally ready for the real world. And here's a really important piece of this. KDDI didn't do it alone. They pulled together this massive coalition of over 20 industry giants. I mean, when you see names like Intel, NVIDIA, AMD, and Dell all working together on this, you know this technology has serious industry backing and a real shot at going mainstream. This was a team effort to solve a huge problem for everyone. And that leads us to the final crucial point. KDDI and their partners aren't just writing a white paper and calling it a day. No, they are actively planning to roll this out as a commercial service. This tech is leaving the lab and heading out into the real world. Which really leaves us with one last big question to think about. As our hunger for data and computing power just continues to explode with AI and 5G, are we getting to a point where a radical solution like immersion cooling isn't just a cool option anymore, but an absolute necessity for a sustainable digital future?